দিদি জয়েন করেছে দিদি কৃষ্ণাদি।
হ্যাঁ 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 ঠিক। Good afternoon, everyone. Now we're ready to start our after lunch first half technical session. For this session, I welcome Mr. Konkon Roy, Assistant Professor, Department of Geography, Kalinagar Mahavidyalaya, as the moderator of this session. Thank you, Konkon. It's over to you.
Thank you, Didi. Welcome back to the third session of this day, of this 7 days workshop on research methodology. Today, we have with us as resource person is Dr. Bishwajit Das, is Assistant Professor of Geography, currently teaching in Manipur Central University. Before joining into the Manipur Central University, he was assistant professor of Salesian College in Shiliguri. So he has some network issues, as we all know that Manipur now is become some disturbances is going on there, and that why he has got some network issues. Fortunately, today he is available with us. Now, without taking much time, I will just over to Dr. Bishwajit Das to start his session.
Thank you, Konkon. Am I audible? Hello.
Yes, you are audible.
So first of all, very good afternoon to everyone. So before starting my lecture, I would like to extend my gratitude towards the teacher in charge of Kalinagar Mahavidyalaya, Dr. Ishani Ghosh, and the IQSC coordinator, Dr. Subhashish Chatterjee, and obviously my friend Konkon Roy. So as the prescribed topic for me is correlation and regression analysis.
না তো ওইভাবেই তো আসলাম, বিরিয়ানি তো লাগতো।
Konkon, just can you confirm that whether you can see my screen or not, Konkon?
Yes, it is visible and audible.
Okay, thank you.
You can start.
So yeah, so as my topic is correlation and regression analysis in social science researches. Most of all, we know that this is the basic tools for any kind of research work. And basically, I have designed this class as a for the UG and PG courses students. I don't know whether it will help for deviation, the mean deviation, and basic descriptive statistic we all know. But for the other students, maybe it's very difficult to understand these things. But I'm assuming that they all knows that the standard deviation, covariance, and variation. So there is a relation between these two, covariation, variation, and the correlation. Later on, we are going to discuss on this thing that how the correlation is related to covariation and variation in the when we try to calculate that correlation. Now, if we try to understand the correlation and coefficient, What is that? It basically the statistical measures for describing two or more variables. What kind of description it is? It is we try to find out whether is there any relation between these two variables or not. Suppose if we give one example that height and weight, right? If we try to establish in a relationship that the height and weight into two variables, increasing with the height, the weight also increase, or increasing with the weight, height also increase. So, is there any relation on the basis of statistical test? Okay, so this kind of establishing the relationship we use the correlation. And if you see other some characteristics of the correlation coefficient, okay, the statistical quantifies the relationship between two variables, and that relationship will be either in positive or negative. Just a second. There is some network issue, so I just off my video. Now in social science, so it gives us direct directions and the degree of correlation. So it gives two things. One is the direction, another is degree of correlation. Direction, whether it is positive or negative, and the degree, it's depend on the value. Right? Now, what are the basic difference values in the correlation? The correlation value is varies from -1 to +1. Okay. So from -1 to +1, this is shows the degree of the relationship. So 1 plus means it's positive or negative, it shows the direction, and the association, how much the association between these two variables is gives the degree of the relationship with the value which is indicating in the correlation coefficient. So the number of, if you see the sign indicates what the strength of the relationship. So how we are going to interpret that relationship? Suppose, as I said, the given examples with increasing height, weight also increase. If the value of this example for the given data, suppose 0.85, positive 0.85. So if it is plus, so it's showing what? It's a positive direction. And the value, it's giving the strength of the association. What kind of strength? Then normally we divide that value from 0 to 1 into various categories. Like, for example, if the value of the correlation coefficient is more than 80, means 0.8, or more than 0.9, so it's nearer to the 1. So 1 means it's perfect correlation. Perfect correlation. Okay, if it is nearer to 1, so the correlation between these two variables is strong. Suppose our example is again height and weight. So we have some data sets. If we try to compare the height and weight with this correlation, and our value is 0.95, so it's nearer to the 1. So if it is 1, then it's called perfect positive correlation. So it's nearer to 1. So we can divide in terms of the degree, right? Or to find out the strength of the relationship. So normally we divide the very strong relationship if it is more than 0.8. Okay, if the value is more than 0.8, then we call it's a strong relationship. So if the given variables, after analyzing the correlation, if the value is more than 0.8, so it's very strong relationship. So if it is 0.8 to 0.6, then we call it strong relationship. Then if it is less than 5, 0.5, then basically we don't take, in social science researches, we don't take this less than 0.5 correlation. We call it very low correlation, but there is, and if it is nearer to the 0, so we simply call there is no relation between the two variables. Okay, so 0 means there is no relationship between the variables, and if it is nearer to 0, then also suppose it's less than 0.2, the association between the children's IQ and parents' IQ. So here, as I say, that there is basically two types of relation. One is positive, another is negative. How we can find out the positive correlation? If one variable increase proportionally with increasing the correspondence variables. Suppose in case of the first example, children IQ and parents IQ. If parents IQ is higher, so basically we just consider that maybe the children's IQ also high. But for the statistical proof, if we do that correlation coefficient and we get the value more than 0.85, then we consider yes, that statement is correct, means there is a positive correlation between these two parameters or between two variables. Same way we can take other examples in case of the social sciences like urban growth and air quality. Okay, if the urban area is growing more or faster way, so obviously there will be the air quality, the deterioration of the air quality, or degradation of the environment. So there is this kind of examples we can take for the correlation coefficient. And what are the applicability of the correlation coefficient in the social sciences? The relationship studies, as I said, that we can easily find out the relationship between two variables. It can be in any kind of social sciences, education, economic, geography, economy, or political science. Anywhere we can use this kind of relationship. Like here, income and education. If we try to find out the relation between these two variables, okay. Then productive analysis, predictive analysis. Although the correlation does not give us the direct prediction, we can't predict on the basis of correlation only, because for prediction we use regression. Okay? But in correlation analysis, it can help us to understand a little bit of the prediction by the correlation coefficient. Then we can see that program evaluations, like those who are working on the different area of the social schemes implemented by the central government or state government. So this kind of schemes, whether it is fulfilled in the real ground or not, for the significant test of that, we can also use the correlation coefficient. And obviously the validity and viability of any kind of assessments. Like after our research work, we can easily try to prove our hypothesis. So that kind of hypothesis proving we can validate through that correlation and coefficient. So types, there are again few types of the correlation coefficient: positive correlation and negative correlations, simple correlation, partial correlation, multiple correlation, and linear and non-linear correlation. So we just try to get some idea of this different kind of correlation, and then we try to analyze that correlation and the formula, how we can calculate the correlation with the given variables. So if you see the positive correlation is what? If we have two variables and one variable increase proportionally to the corresponding variables, then it's called positive. As I said, with increasing, suppose the rainfall, the productivity is also increased. Okay, suppose if the rainfall is in and same way, the production, which is y variables, is also increasing from 20 to 40 to 60. Okay, so there is what in that there is a direct or proportional identical throughout the variables. The the changes of the variables is proportionally identical. So with increasing the value from 2 centimeter rainfall to the 4 centimeter rainfall, the productivity of the same land is increasing by double, means from 20,000 kilo to the 40,000 kilo. And for better understanding, we have given one simple scatter plot, which actually showing the same kind of correlations, okay, amount of the rainfall and rice production. So this is an example of the correlation. But what is the correlation value? Suppose after analyzing this data, we get correlation value with 0.85. So in this diagram, we are just assuming one scatter plot with the line and the x and y variables, and this correlation's value is given, suppose 0.85 R value. So now, what this 0.85 value is indicating? This is indicating that there is a very strong relationship between these two variables. Suppose we can assume that x variables is our rainfall and y variables is our production. So if we compare or if we correlate this x and y variable, so our correlation value is 0.85, which is indicating there is a very strong relationship between these two variables. And as it is in positive plus sign, so we can say there is a positive, very strong and positive correlation between these two variables. Same way, if we try to see the negative correlation, the correlation between the two variables is said to be negative when one variable is increased and the corresponding variables is decreased. So suppose now it is with increasing the rainfall, the productivity is decreasing. Okay, then this type of correlation we can say that this is negative correlation. If you see this data and the scatter plot is what rainfall in same centimeter and the production is decreasing. For 2 centimeter rainfall is 80 and similarly it's decreasing, value is decreasing, so the value will be negative. Okay, so this is called the negative correlation. And if we try to think that what will be the exact value for this kind of relationship, maybe for this will be the scatter plot. We can assume this will be the scatter plot from the given data for the x and y variables. And from here we can assume that the value is decreasing with increasing the x-axis. Okay, when we are going this direction, the value is what decreasing. So one hand y variable is increasing, on the other hand the x variable is decreasing. So it's showing the negative correlation. So this is the strength of the relationship, as I said earlier, that the value is showing the strength of the relationship. The plus sign and minus sign is showing the direction, whether the relation is positive or negative. It's giving us a direction. But the strength is of the relationship is depend on the values. Okay. Now here are there is 4 scatter diagram with the correlation value. So can we think that what interpretation we can make based on that scatter plot? The first one, the value is R value is 1. 1 means this is perfect, and if it is in plus sign, we can see this is in positive value. So this is what is exactly perfect positive correlation. And otherwise, we can try to understand by the scatter plot also. Why? If you see this correlation line or the line and the scatter value is exactly fitting on that line. So this means it's a perfect positive correlation. And second diagram, if you see the R value is 0.8, it's also indicating the positive correlation, but the that scatter plot is not exactly same with this. Okay, it's not exactly matched with this regulation or the line. So it's what there is a relationship, positive relationship, but it's not the perfect positive relationship. So we can say the degree of this value, like 0.85, is obviously less than 1. So this way we can say, or we can interpret this diagram as strong positive correlation between these two variables. Suppose here is our x and y variables, so we can say there is a strong positive correlation, but not perfect correlation. But in case of this diagram, it is a perfect positive correlation. Same way, this is a very low correlation, means the value is 0.42. As I said, if it is less than correlation, simple correlation is involved what? It's simply study only two variables. If it involves only two variables, then it's called variable will be the neutral, and other two variables will be playing the major role. So when we use this kind of correlation, perform this kind of correlation, then it considered as a partial correlations. And multi-correlation, we know that if the variables is more than 2 or more than 3, okay, then we call this multi-correlation. For example, the study of the relationship with the yield or the production of the wheat per acre. It's depend on the rainfall, it's depend on the fertilizers, or maybe it's depend on the other factors, maybe soil factors, soil moisture, everything we can compare. So this will be the example of the multi-correlation. And then again, it's linear or non-linear. Linear means if the amount of change between two variables is constant, it's constant, then it's only called as linear. Okay. Means the change, the amount, suppose one variable is increasing from 1 to 2, and the next variables, the corresponding variables, is suppose increasing by 100 times. So from, suppose we can say the x-axis or the x variable is 1, 2, 3, 4, 5, and the y variable is 100, 200, 300, 400. So with increasing 1 unit, there exactly in a constant rate, it's increasing 100. So this is called the linear correlation when it's increased with the constant ratio. And curvilinear, or we can say the non-linear correlation, it's when the change, the amount of change is not constant in a constant ratio. Suppose both are increasing, but not in a same rate. Suppose the x-axis is 1, 2, 3, 4, and y-axis is 2, 5, and 7. So interval is not same. The ratio, the changing ratio is not perfect. So it's not showing as a straight line. If you see the scatter diagram, it's not showing the straight line, it's showing the curvilinear line, a curved line. So this is called non-linear regression or curvilinear regression. If you see the diagrams, in this case, the scatter plot is showing, and if you see the lines, it's perfectly straight. But here it's curved. So the basic thing is the ratio of the changeable variables is not constant. So next is method of studying the correlations. What are the different method of correlation? Normally we study the by using scatter diagrams, curl Pearson coefficient, and rank correlation method. As I said, the scatter diagram is what by scatter diagram we try to find out the association between two variables, but in a visual form. In a visual forms, right? In case of the direct correlation method, we get the correlation value, we can find out the strength of the relationship or the direction of the relationship. But in case of the scatter diagram, we show the visual and the visual interpretation is the most important. The clustering of the scatter plot, it's showing the result. Like here, in case of the scatter from the scatter diagram, we can assume that there is a positive relation but not so strong relationship. If we get the value, then we can get easily understand what are the score. But without the score, we can assume that whether the relationship is positive or negative, or the strong or not strong, we can means identify, but not exact, because exact value for the exact value we have to do the correlation analysis. So these are some examples from where we can see from the scatter plot how we can identify which one is the perfect positive, perfect negative, or the high positive, high negative correlation. Means from without the value of the correlation, we can assume from the scatter plot that the relationship between these variables. Like first one is showing the perfect linear because all the scatter points is in the same direction in a perfect positive line. If we draw a line, it will be fit exactly with the scatter plot. So perfect positive correlation. Second one, you can see this one is the perfect negative correlation. Here is the positive correlation, but the degree is low. Association is low. Here is the negative, but its association low. Here is the high positive. How we can assume that this is the high and this is the low? We have to assume that the perfect positive line should be from the intersecting point of the x and y axis from here, and it goes like this directions. So if it is above this, so it is high positive. If it is nearer to this line, so it's positive, okay, or low positive. So this way we can assume from the scatter diagrams, and this too we can say there is no relationship between the, because if we try to draw a line in between the scatter plot, so it will not fit either it's not in the positive side or negative side. So it's very difficult. So we can say there is no relation between these two variables if we can see this kind of scatter plot of the data. Now, the first thing I was studying with the definition of correlation is what? Correlation analysis covariation between two and more variables. So now I'm studying again because to understand the correlation concept, we have to understand first the standard deviation, variation, and covariation. So in case of the variation, no, we see what? We see the differences from the standard deviation. Differences from the standard deviation, right? So, and in covariance, what we have seen, so the variance is statistic for describing the variation of a single variable. This is most important thing to remember. What that variance is a statistic to describe the variation of a single variable. But in case of covariation, it describes the correspondence variable also. Okay, so in case of covariance, there will be two variables, and in case of variance, there will be one variable. So if you see the formula of variance and covariance, okay, if you see the formula for the variance is summation x minus x bar and again multiply by x minus x bar divided by n. N means number of observation. So x here is also x minus x bar, x minus x bar means what? There is the single value in case of the variance. And in case of covariance, you can see the formula summation y minus y bar and x minus x bar. So there is two variables, one is x and another is y. So there is the difference between variance and covariance. And how the covariance is related to the correlation that I'm going to explain. So variance is based on the square of deviation from the mean, okay, and covariance is based on the product of two set of the variation from the mean. So both is showing the deviation. Both are showing the square of the deviation from where? From the mean of a data set. Is it clear? So from the mean of a data set, covariation and variance both are fine. Now if you see how it's related with the correlation. Basically, correlation is what? Covariance divided by the standard deviation of these two variables. Suppose we have variable x and y. So, formula of that covariance, the correlation, you can see this formula R. R value is what? It's actually covariance divided by standard deviation of x and standard deviation of y. Important for the social. So, he used this product moment correlation during his research work with the specimen copy with the different kind of species or in the biological studies. But now we are using in social science also because this is the one of the best simplest method to prove our hypothesis. And this formula is known as Spearman rank correlation formula. So 1 minus summation d square by n cube minus n. So here you can see the rank d1 is the difference in rank between the ith pair of the ranks. So we are going to discuss this thing in details in next slide. So if you see that calculation coefficient formula, this is the simplified formula of that previous formula. Okay, this is the actual formula of the calculation or the correlation. And if we simplify, because here all the x and y variables is written as the capital X and capital Y, but in the simplified formula, this all are the small x and small y. So small x equals to what? Capital X minus x bar, and small y equals to y minus y bar. So if we simplify this formula, it comes like, we can write like this, summation xy by root over summation x square plus summation x square. So here R is the product moment correlation coefficient, and deviation taken from the x series from the mean, and y is the deviation from the y series of the mean. Because we know y bar is the mean and x is the mid value of that data series. Okay. Now we have I have one data here for the calculating the Pearson correlation coefficient. where the fertilizer use in 100 kgs x-axis and crop production for the y-axis. So based on the formula, we have to analyze this first. Like I have designed this, as I said, for the UG and PG courses. So I have shown all this kind of slide here, so they can easily calculate and find out the value of the product movement correlation, and then they can try to interpret. Okay. So I'm just skip showing this thing once. So this is small x, which is x minus x bar, y minus y bar. This is the small y, and this is the small x square, small y square, and this is small x and small y, multiplication of small x and small y. So if we try to solve this equation, this problem, you can see these all are the values, summation x square. I'm not going to say all details. Just this, if you know this formula and if you have this value, so you can easily find out the rank coefficient of correlation. Just simply you have to put this value, summation x, y, summation small x, and summation this value you have to calculate. So 43 divided by lower 32 into this. So if you calculate, you will get easily 0.896. The most important thing is not the calculation point. Most important thing is to interpret that value. So you will get the value after your two variables, where whatever variable you will try to compare. After comparing, after calculating, obviously you will get some value, right? So the most important part is how you are going to interpret that value. So as it is in positive, so we know that, and the value is 0.896. So which indicates what? It's a positive correlation. And the association, if you see, the strength of the relationship, if you see, this is what? It's strong relation, strong positive relation. Why? As I said, the value, if it's more than 0.8, we can consider it's a very strong correlation. So from this interpretation, from this value, we have to interpret that the relationship between x and y variables, in case of this, it's fertilizer used or maybe the production of the crop, is showing what? Very high positive or correlation between two the variables, as the R value is 0.896. Okay. So this way we have to interpret, and then only it will be giving the support for our the hypothesis if we choose any kind of hypothesis in our research. And next one is the Spearman rank correlation. Again, if you same thing, if you know the formula and if you have the data, calculation part is very easy. But the same important thing is your interpretation here also. But the basic difference is for the Spearman and the calculation is what? If you have the interval data, you have to choose what? You have to choose the Pearson method. If you have ordinal data, then you have to choose Spearman rank correlation. So here, if you see the formula is what? Summation t square is what? Difference of ranking. Now, as it is ordinal data, so we have to see the differences of ranking. And the total number of the data is previous variable. So this is n means the total number of observation in the field. Here you have to see some kind of the calculation part. First, maybe you have that kind of normal data. Then if they give, mostly for the student perspective, if it is in syllabus, so they can try to think that if the whole number of data is given, then they have to convert it into the ratio form. Or if directly ratio is given, then they have no need to convert into the ratio form. So average monthly temperature in degree Celsius and electricity bill in rupees. So you can see 38, rank 1. Rank 1 is given for 43, okay, which is the highest value, 43. Then 41 for the second highest. So this way we have to give the rank for entire data set. Okay. Then we have to see the difference between the ranks. Like for the first one, rank 1 is 3 and rank 2 is 4. So what will be the difference? 3 minus 4. Okay, you can see it's minus 1. 3 minus 4 is minus 1. And 5 minus 5 is 0. 7 minus 7 is 0. 8 minus 8 is 0. 4 minus 3 is 1. So this way we have to find out the differences and then difference square. So here you can see the difference square is 1 and 1. So if you add this, if you find out the summation of this square is 2. Now simply you can put this value in this formula. Okay, 6 total number of observation. 6 is here and summation t square is 2 and total number of pair is 8. So 8 cube minus 8, if you try to calculate it, you can easily get the correlation value. It's 0.98. So what this value indicating? It's indicating there is a positive, strong positive. It's near to the perfect positive. If it is 1 plus 1, then we can say it's perfect positive. But it's very, very strong positive correlation between what? The temperatures, increasing the temperature and the electricity bill. Because we know then the part of our interpretation, then we have to interpret what due to the temperature we use more electric appliances like AC, fan, then the electricity bill also goes high. So this is the other side of the story of the research. Okay, not only interpreting the result, but we have to think beyond that. What is the factor for this kind of correlation, right? So there is another calculation for the rank correlation if there is equal rank. So I'm just saying only one thing. If there is equal rank, then we have to divide that rank. We have to add this two rank and divide into same ranks. Like here, first one is rank 1, second one is 2, and then third one. Okay, if you see the third, 20, 22 and 23. So 23 and 23, both are the same. Okay, so in this case, you have to do what? Simply add the third and fourth rank. So 3, if you add 3 plus 4 is what? 7. 7 divided by 2 is 3.5. So you can see for 23, we have given 3.5 and again for 23, we have given 3.5 rank. So this is the basic difference between the equal ranks method. Okay, so we have to distribute the ranks this way. And what will be the next rank? So 3 and 4 is gone. So next rank will be the 5. So you can see after 23, 24 is the next rank. So this rank is given as 5. So there is no 3 and 4 rank in the rank data. There is no 3 and 4 rank because we have had this 2, 3 and 4 and divide by 2. So 3.5 rank is given for 23 and 3.5 we are given is for the 23. And next rank will be starting from the 5 because 3 and 4 rank has gone. Okay. And after 5 there is 6 rank. You can see for 28 we have given 6 rank, for 28 6. And then after 6 there will be 7 rank, right? Again you can see 30, 30. There is 230. So we have to again add this 2 rank. So after 6 it will be 7 and there was 8. So 7 plus 8 is 15. So if we divide by 2, then it will be 7.5 and 7.5. So this way we have to distribute if we have the equal rank. Maybe instead of 2 rank, we can have 3 same number, right? So then also we have to do the same way. We have to add the same 3 ranks, then divide by 3. And then we have to give the ranks. And rest of the things is very similar to the previous one, right? Like rank 1 minus rank 2, d square, then formula also almost same. The slight difference is there. How many repeated rank is there? You have to write this formula in that many times. Like here it's repeating once and twice. So, and here it's repeating once. So to the next part.
Excuse me, sir. Sir, we are giving rank here from lowest number. So can't we rank?
Yeah,
Can't we rank the number from the highest one?
Yes. That we can.
That can be done. Okay.
Yes. Right. So in other words,
ইয়া
হুম।
ঠিক আছে, থ্যাংক ইউ বিশ্বজিৎ বাবুকে থ্যাংক ইউ দেওয়ার উচিত।
থ্যাংক ইউ স্যার, থ্যাংক ইউ বলবেন না। আর